All right, so I'm going to be doing a presentation on Packer. We're talking a little bit about practicing. That's kind of what this talk came from. I do this stuff in my home lab, so at the end I'm going to show a little video that kind of quickly goes through a Packer build. But yeah, fully agree, practicing, have to keep learning this stuff. We unfortunately, or fortunately, depending on your perspective, chose a field that you can never stop learning, or you will, be out of date fairly quickly. So, yeah, always have to be practicing this stuff. So, my name is Kyle Sexton. I am a senior DevOps engineer at New Context. Same company. Find me online and whatnot. So for those of you who don't know, Packer is an open source tool for creating machine images. You can use it to create images for Vagrant or for VirtualBox or for like Amazon or Azure. Basically, you're creating your base image type stuff. Who here has never even heard of Packer? See, I like doing these things because I think everybody's used Packer. They probably all use it all the time. Nobody's going to want to hear this talk. And then I look at it and it's like, oh, people haven't even heard of it. So hopefully you will walk away from this thinking, I'm going to go home and do some Packer. So why would you want to do this? Continuous delivery. So one of the things that when most people talk about what is DevOps, this will eventually come up, right? Continuous delivery. Packer can be placed into your pipeline to generate new machine images automatically. So this kind of helps enable a portion of continuous delivery. Environment parity. Keep your development staging in production as similar as possible. So how many people here are doing like Amazon EC2 images, right? If you're doing those, and say you're using like the Amazon Linux, but your dev environment is using like CentOS, that's not actually the same thing. So will you find the same bugs in your dev and stage that you will in production? Maybe, I don't know. So with something like this, you can have your dev environment be closer to what your production environment is. And appliance creation. So a lot of software companies just package up an AMI and say, here's version 5.2 of our new thing, download this. Create images, you're doing a DevOps kata book with an image. It's an appliance. You use exactly for that. Benefits. No more handmade golden images. Audit trail for changes, because you can just go to because your image is coming from code now, you can just go right to your version control, and you can see what changes were made just by the latest commits. And consistency. All the images are going to be made the same, no matter who decides to build it, because it's going to be always built the same way. So these are probably some bad sort of examples around like things that I have seen. So maybe you've seen these, hopefully not, but they're things that I've seen that you kind of run into when you're doing infrastructure builds. Someone forgot to sysprep the latest Windows template, and then you have a data center full of Windows VMs, all with the same sys ID, or SID. Not good. But I've seen it happen because that's like the last step, and you're trying to leave at 5 o'clock on Friday. You're not going to remember to sysprep this machine. You got to go. We killed UDEV rules on our latest Linux builds. So like this constant thing where if you don't delete this little rule at the end of your building your new VM, when it boots up, it won't get networking. So all these things just like kind of eat up time and things you run into. To get started with, it's pretty easy. It supports all the things that the stack exploit was just put on. So.
And more.
Yeah, and more. And it's homebrew, so also if you're on a Mac, probably a whole other talk on homebrew, but yeah. Brew install on a Mac makes things super easy. When you get started, what you're going to do is you're going to build a JSON file that kind of describes what your image should do. So it's got variables, which our variables. Builders define what kind of machine you want to create, and then what you want to do after the machine is created. Here's kind of what it looks like. I will show that in a second. This is awesome because I actually just did this as a live demo, so I have this, but now it's going to be a video because time constraints, so nothing can go wrong, right? So real quick, this is kind of what the code looks like. Oh no, just gotta send this over to the next machine.
I gotta see it one more time.
Run away!
The horror movie.
Well,
I gotta figure out how to get that off that monitor.
that's actually the landlord. The spider stopped paying rent.
So can anybody actually read that? All right, so this is kind of what the code looks like. You have the variables thing that I talked about at the top. These are just kind of things that you're going to change later. You have builders, the one I'm going to show you. So we're talking about practicing. I have a VMware environment for my home lab. I find it really nice to be able to like spin up, nodes of things. A lot of projects have like there's Minikube for Kubernetes and things like that. They're sort of all in one. I like to spin up kind of what an actual infrastructure would look like. So have like 4 nodes or 4 nodes with a master and kind of see what happens if I turn this one off. What does it do? That kind of stuff. So I use this to build my base image for my lab stuff. So yeah, basically builder, VMware ISO. The way this works is kind of cool. So when Packer goes and does its thing, what it actually does is communicates over VNC to the machine and does it types in, so it pretends to type for you and gives you a Kickstarter URL, and then that machine comes back, it launches a little internal web server to spit out a Kickstarter file for CentOS to install. So you'll see VNC stuff, all that kind of stuff, and then this is kind of the important part right here at the bottom. Post-install scripts, right? So this is just the stuff that I kind of have for my home lab, but I've seen people use this for we want to lock every machine down to the CIS security rules. You can do that in this type of thing. But every machine you build will have those rules applied, and you can have a receipt for every change to this. So hopefully you guys can see this. So what I'm doing here is I'm running this Packer build, and I've given it my variables file, which has passwords, things like that. I keep it in a separate file so I don't check it in. And then I gave it that file that you just looked at, the JSON file that describes how I want CentOS to be installed. Does its downloading of an ISO, uploads the ISO to the remote machine, starts this HTTP server, and then over here you can see actually what it's doing. So it's typing, as I was just saying, typing in all that stuff. It says, hey, when you boot up, go to this Kickstarter address, do this thing. And so this is actually, if you were looking at the console on this side, what the machine is doing as it's being installed and set up. And this is the sort of Packer output, right? So it's done its main thing so far, so it's going to wait for SSH. Because it's given it the kickstart, told it everything to do until SSH comes alive. And the cursor's blinking really fast because I sped it up. Should also get the talk on how to do crazy things in QuickTime that it was not meant to do. It's like clipping things, and yeah, it was not good. So cool, it's finished its install. It's rebooting, coming online. Hopefully soon SSH should become available. Then Packer goes and it does its thing, right? So it's doing all those post-install scripts that define how you want your machine to be built. Throw this in your pipeline, and you're suddenly getting consistent builds. You know, any change to it, you see it, works really well.
This goes a lot faster than mine.
There's some windows though, right?
But it's building a Ubuntu image on Windows. Yeah.
Build finished. So hopefully, go back to VMware environment, and you'll see CentOS 7. Great, there's my new VM that I just made. That's all. So I went really quick because I had 10 minutes, so I tried to keep it in 10 minutes. So questions, let me know.
How big is that image when you're done with it, the CentOS?
That's a good question. If this wasn't a video, I would show you. But what it does do during one of the post-installation scripts is it runs a minimize. So it fills up the entire image with a bunch of, like dev zero. It makes a really big file, then deletes that file. So all your real data is at the front of the image, and then it can be compressed down. A really cool project, it's the Bento project by Chef. They have a bunch of pre-made sort of like CentOS, FreeBSD, Mac, Windows, like all the JSONs that you want, you can use as a start.
So I use shell scripts and then Puck. And there's a fairly hard cutoff between those two things for setting EC2 instances, for example. Is there an overlap, or I don't know how familiar you are with Puppet, but how much of an overlap is there between what Packer does and what Puppet does? Or is there a hard cutoff in your mind between what you want to do?
So when I think of Puppet, I think of like ongoing configuration management. You know, it's like I'm going to check every X minutes and say that I want this machine to match, you know, what I specified this machine to do. If someone changes that, go and fix that. This really fits in line with how do I want that machine first to be built, right? So most organizations, when they're bringing up images, they want to have some sort of gold standard, something that security said, okay, we've done our audits of this machine. When you fire it up, it's at least not going to get hacked in the first 5 minutes or whatever. So, you know, this is your gold image. From there, you can apply your tools. And you can also use these tools you can bake in. So if you don't want to do, you know, like you can, like your cloud init can, you know, automatically download your Puppet installation and do all the setup. So you don't have to worry about that stuff doing however you're doing it now.
Can I add that?
Yeah.
Some people have explained to me, and I haven't had the opportunity yet, that the line is for auto scaling. Like you put the Puppet on this side. So like when you're auto scaling, you're not, let's say you got a 3-minute Puppet run, you're not incurring that cost when you go create a machine. That first time you run Puppet, it takes 3 minutes. Next time it takes like 2 seconds, right? Because of idempotency. So like if you move that over here, then your auto scaling goes much faster at the time you need it.
Yeah, another big point with that is like yum updates, right? So like when they first do the image, you know, it's super fast because they did a yum update at the end. But you know, 4 months, you're still on Cent 7.3. There's like 500 megs of download that you're doing every single time you do your new machine build up because it's got that yum update built in. Well, if it's in your pipeline, you can just have new builds kick off whenever there's an update, whenever you have your however you want to do it, but you can make it a much more quick iteration between builds. So you're not having to do those types of long processes.
So you still do that config management over here, but the yum updates, all the stuff just makes it go so much faster when you do configuration management.
You can chain them together too. The learning VM that I have is based on a box, on a 1604 Genial box directly from Canonical. And then to go, that build takes half an hour, which is why I know that exploit's not in it, because I rebuild it every time. So if it's in that, I do the dist upgrade on Ubuntu in that image, and so it gets all the updates. That build takes half an hour to 45 minutes. To go from there to learning VM takes maybe 10 minutes. And then from there, I expect to use Kitchen and some other things so that if you download the VM, you can run a Kitchen file or something like that. If there's an update to the VM, you don't have to re-download the whole image, you can just download the script.
Going once, going twice, other questions? All right.
A round of applause for the crowd.